So today we're going to start talking about solving trigonometric equations and inequalities. A couple rules here to follow. If the variable is restricted to two adjacent quadrants, the trig equation will have fewer solutions. These are called principal values. For sine x and tan x, the principal values are in quadrants 1 and 4. So x is in the interval negative 90 to 90. For cosine x, the principal values are quadrants 1 and 2. So x is in the interval of 0 to 180. This is similar to what we were talking about before. Really? You don't want to be here, take off. No problem with that. Here we go. We've talked about the domains, restricting the domains before. And we talked about tangent and sine and cosine. Remember, I had tangent mixed up. It's quadrants 1 and 4. And originally, when I said it, I said 1 and 2. So it's the same as sine. But anyway, what we're talking about when we do that is they're all the values of sine and cosine can be covered in this part of the circle. All the negative values of, I'm sorry, I didn't mean to say sine and cosine. All the values of sine and tangent can be covered in this part of the circle because all the negatives would be down here and all the positives would be up here. If we didn't restrict the variable, and remember we would have multiple answers, infinitely many answers, because we would keep going around and around and around the circle, and it wouldn't stop. Okay, so they will restrict the domains for you. So pay attention to the questions. When they ask the question, they'll tell you where is x located at. Okay, and you have to find all the values that are appropriate to that answer within that range of x values. Okay, so I have just a couple examples here. Those are really only notes we have. Pause while we find the directions on that. So the directions here says find the solutions for the equation for the principal values of x. So the word principal values is what's restricting our domain. And so sine, remember, is quadrants 1 and 4. Okay? So we want to find all the possible values that match this in quadrants 1 and 4. Okay? So, if you notice, there's no parentheses here, right? Those parentheses I just drew in were not there. And so that means that we're really looking at this. So sine of 2x is equal to a positive 1. You agree with that? Okay. Sine of 2x. Man, that looks like an identity, doesn't it? So what kind of an identity?
Angle.
Double angle identity. And so what's the rule for double angle identity? 2 sine x cosine x. And that's all equal to 1. So what do you think I could do next?
Since if the x value and if the x value, okay, so if an angle for sine is complementary with the angle for cosine, then if multiply they equal 1. So you do x equals 30 degrees, and then twice the value would be sine of 60, right?
Twice the value of sine of 30 would be sine of 60?
It's not distributed between the two. Exactly. So then cosine
Well, you can't,
multiply.
x is the same number.
Yeah, yeah, but, because x would be 30 degrees.
Well, cosine 30 times cosine, I'm sorry, cosine 30 times sine 30 times 2, you think is 1?
Or no, 2 times sine 30 times cosine 30.
Switch the cosine to 1 over sine x.
Well, that's.
It'd be 1 over secant, right?
There you go.
I like where you're thinking, but
Yeah,
actually this is kind of tricky, this first step here. We have two trig variables, or two trig functions going on here, and we need to get down to 1. And the only rule we really have for sine and cosine that relate them to each other, is the sine squared
Yeah.
plus cosine squared is equal to 1. Right? That's the only one we really have. And so, what we want to do here is actually square both sides. And so, we could have moved the 2 over first, made it 1/2, and then squared both sides. But when I do that, I have to square, because someone pointed out, this is not distributive property here. It's 2 times sine times cosine. So when you square that, you have to square each factor. And so I get 4 sine squared x cosine squared x equal to 1 squared, which is 1. Okay? I'm going to get that 4 out of there. I'm going to divide both sides by 4. And do you agree that cosine squared is equal to what? What's cosine squared equal to? 1 minus sine squared. And so I can say sine squared x times 1 minus sine squared x is equal to 1/4. Okay. Where did she get the... Oh, I made a mistake. I'm sorry. I made a mistake. I forgot where I had to go. Oops. I don't want to move that over. The reality is I'm going to end up with a quadratic. I'm going to need to set it equal to 0. And so I'm actually going to have to eventually move the 1 back over. Okay? And so when I do this, I'm now going to distribute. And so I get 4 sine squared x minus 4 sine what?
4x.
Sine 4th x, yep. The 4th power of x. Okay? And I'm actually going to move both of these over there now. And I'm adding, so this minus this, when I move it over there, it's going to be what? When I move it over there, for those at home who can't see me pointing. It's going to be positive, and this positive one, when I move it over there, is going to be negative. And I'm going to have 0 left here. And this is the highest degree, so I'm going to write that first. 4 sine 4x minus 4 sine squared x plus 1, because that 1 is a positive number, plus 1. Now, this really gets ugly before it gets pretty. Okay? What we have here is we have this concept. We have 4x squared. Let me try this again. I'll choose a different letter than x, so I'm going to say 4a squared minus 4a plus 1. And that factors into 2a minus 1 times 2a minus 1. Okay? Which is 2a minus 1 squared. This is how this factors. Okay? A here represents sine squared x. And when you square sine squared, we got sine to the fourth, didn't we? And so what I have is 2 sine squared x minus 1 times 2 sine squared x minus 1. Okay? And so, I can go ahead and write it as 1. But then I'm going to solve by square rooting both sides. And so I'm going to get 2 sine squared x minus 1 equals 0. And I have to get my sine x all by itself. So what am I going to do? Add 1 to both sides. 2 sine squared x. And then what am I going to do? Divide by 2. So I get 1/2 equals sine squared x. Now what do? Square root it. So sine x is equal to square root of 2 over 2. Sorry if I left you there. It's 1 over square root of 2, but when I rationalize, I get that. Square root of 1 is 1, square root of 2 is square root of 2. Okay? It would. Would. Yep, it would. At this point right here, we have to be careful because we didn't know what we had in here when we squared it. We got a positive. So once we square root it, we get plus or minus. Sorry, this side. Once we square root it, we get plus or minus. I want to look back at what the original looked like. If we go back to here, that makes sense. 2 times 45 is 90. Sine of 90 is 1. Minus 1 equals 0. Now if I put negative 45 in there, I get negative 90. What's the sign of negative 90? It's negative 1, right? Sine of 270 which is negative 90 or positive 270. The sine of this angle here is negative 1, right? Negative 1 minus 1 is not 0, is it? So even though we had a plus or minus here, the minus one doesn't work. So we say x is equal to 45 degrees.
I'm guessing they aren't always going to be values like 45s and 30s and 60s.
Trying to think. I don't. They actually are, but they're not always. They're not always in that principal values. Sometimes they're in other quadrants. Okay. All right. The next one I chose was number 20. What's the rule for tangent?
Same for cosine.
What is it?
X has to be between negative 90 degrees and positive 90 degrees. Or do you want to know?
No, I meant, what's the double, this is a double angle, right?
Oh.
So what's the double angle rule for tangent?
Tan 2x equals 2 tan x
Yeah.
over 1 minus tan squared x.
I'm gonna add my square root 3 to both sides. I know we want to set it equal to 0, but this is in the denominator. And so we have to multiply both sides by that number. So we get 2 tan x equals square root of 3 minus square root of 3 tan squared x. Okay? Now, there's a couple ways we can look at this. If I'm factoring something like this, let's just say I'm just factoring something like this, okay? I don't want this coefficient to be negative. Making that negative changes all the rules that I use when I'm factoring, okay? And so I think it makes it a lot harder if we make that negative. So we have two ways of dealing with this. I'll leave it up to you which way you want to do it because you're the one writing it in your paper. We can either move these two over here, or we can move this 1 over there and divide by a -1. What happens if I divide every term by -1? Changes the sign of every term, right? So how do you want to handle that? You want to move both of those over here, or we want to move this over there and just change the signs?
Move it over there and change the sign.
Okay, so we get 0 on this side. I'm going to write this term first, so it's going to change to a positive square root of 3 tan squared x. Okay. When I move this over, it made it a negative, right? But when I change the sign, it makes it a positive 2 tan x minus square root of 3, because this one's already over there and it's positive, so when I change the sign, it's negative. Okay. Let's double check. This is positive, right? Boy, that was slow, wasn't it? This one here is positive, and when I move this one, if I had moved this one over here, it would be what? Negative. And when I move this one over here, it would become positive. And so we have the correct signs here. All right, now we want to factor. I'm just going to check, make sure there wasn't some simple fix. I can do that. No, there isn't. This tells me my signs have to be different. And I need square root of 3 times tan x. And so one of these has to be, I'm going to put my signs in, but I might have to change them when I'm done to get the right sign. Yeah, I think I put them in backwards. I did. And then how do I get square root of 3 here?
Square root of 3 1.
Square root of 3 times 1. And I need, I'm just going to put it in. I did put my signs backwards. I'll have to change them. You might just guess and put them in and then have to switch them if it doesn't work. What do those two give me?
9 10 no 3 10x.
It gives me 3 tan x, right? Actually negative, right?
Yeah.
But this gives me a negative 3 tan x. What do these give me?
10x.
Positive 1 tan x. Well, that add them together gives me a negative 2 tan, right? Well, I want the 2 tan, but I want it to be positive, so that just means, okay, I made a mistake. When I just stuck those signs in, I put them in the wrong place. This should have been minus, that should have been plus. So if I double check that again now, I get a positive 3 tan x, and a negative 1 tan x gives me positive 2. Okay? So that's how we factor that. And so that gives me two answers. Square root of 3 tan x minus 1 is equal to 0, or tan x plus square root of 3 is equal to 0. Okay? So if we solve this one, square root of 3 tan x equals 1. So tan x equals 1 over square root of 3. If I'm going too quickly, you need to say, wait a minute, how'd you do that? Don't let me go too fast. These equations get kind of ugly because of all the trig functions, but the reality is, it's exactly the same skill that you had to use in algebra when you're solving equations. We're doing the same things, it's just that now they're much more complicated looking. Okay? If you don't remember what that is, if you don't see, well, that's either a 30 or 60 degree angle, and picture your triangle and sort it out, you can always do this. The calculator will tell you the answer. Okay? The problem the calculator won't do is make sure you get all the answers in the proper quadrants. They'll just either give you a positive or a negative angle. And you have to go back and look at the directions and match it up. And so we'll hold off on that. We'll come back to it. Tan x then is equal to negative square root of 3. And so x is going to equal inverse tan of negative square root of 3. Again, we're talking, one of these was 30 and the other one's going to be 60, and one's going to be negative.
The first one is a 30 and the second one is
So
negative.
this one x is 30 and the other is negative 60.
Yeah.
Okay. So then, did it say principal values yet? Was this the same kind of?
Yes.
Okay. And so if we go back to, can I move it up now? If we go back to here, and I put negative 60 in, what's 2 times negative 60?
No, positive. Wait.
2 times negative 60 is the negative
Yeah.
120, right? And so negative 120, tan of negative 120 is
30. Because it's positive 240. Right?
tan of a negative 120. Should give me like a negative square root of 3, doesn't it?
Well, it has to get it to equal 0.
Well, negative square root of 3 minus square root of 3, though, is not 0. I don't have that crossed off, though. So. I have that as an answer, not as a, but I don't think it is. Yeah, they have as an answer too. Okay. I thought it was extraneous. First thought on that was that's not gonna work. It's gonna be, we didn't do anything wrong, that's the answer we got, but we didn't check. That's what I thought was happening there. Guess I'll have to look at that a little closer.
Gibby!
Okay? They had both of these working. I know this one works, and I questioned whether that one worked. Just take your calculator, what's the square root of negative, I'm sorry, what's the tangent of negative 120? What is it?
Square root of 3 minus the square root of 3 is 0.
Oh, I'm sorry. I was totally brain dead on that. I was picturing this, and Max was trying to tell me it's a 240. He was trying to say it correctly, but I wasn't hearing him. Yeah, it is. They do both work. I was picturing this 120. Even though I'm saying a negative, I was not hearing myself say negative. A negative 120 is this one down here, and tangent is positive in quadrant 3. So absolutely, I agree. These both work. Okay? All right. So our assignment today is 17 to 30. Try again. 17 to 29. That's not many, but as you see, they're kind of long and involved. Okay? And you need to